Hi, welcome back. We're going to continue a few more examples using integration by substitution. And I'm hoping by now you kind of realize it's nice sometimes if we don't have to replace u. So let's take a look at another example. Something like maybe let's get some trig going on here. From 0 to pi over 2. And we can write, we'll use cosine cubed of x times the sine of x dx. Now I want to evaluate this. Now remember, we're looking for the area under a curve. So the first thing I'm going to do is when I try to integrate this, is I need to find out what my u is going to be. And if I look here, this cube right there, remember this is really saying it inside. This is like saying cosine of x cubed. And that helps me pick my u. So I'm going to let u be the cosine of x. My du is going to be negative sine of x dx. And I would get dx equals du over negative sine of x. Now when I rewrite my integral, I mean my favorite mathematical pickup line, u cubed times the sine of x du over negative sine of x. And of course, just like before, those sine of x's cancel. Now notice I did not replace my domain yet. I'm going to replace my domain after I change everything. So what I'm left with now is this negative, can factor that negative out, u cubed du. So at this point, this is where I want to change my domain. Well, when x is 0, u is going to be the cosine of 0, which is just 1. When x is pi over 2, u becomes the cosine of pi over 2, which is 0. Now notice, even though here it's like 0 to pi over 2 is small to big, here it's big to small. We don't change the order at all. Don't change that order. Okay? Remember we got that negative. What does that negative mean? It's going to change my direction anyway. So we're okay. We're okay. We're going to be fine with this example right here. So we never change the order no matter what it gives us. So my integral, I'm going to make this a 0. Whoops, sorry. When x was 0, this should be a 1, and this would be 0. So when we integrate, we're going to get negative u to the 4th over 4. We don't have to put the c1, remember from the other day, that's just going to cancel. And we're going to evaluate that from 1 to 0. And then we use the FTC. What this says is take f of 0 minus f of 1. So if I plug 0 in, we're going to get negative 0 minus, plug the 1 in, a negative 1/4. And what we're left with is just a number 1/4. Now, be very careful. When you're doing u substitution, are you ready? When you do u substitution, we're changing literally everything into a u. All the x's become a u. Even the x's up here. Remember, this is x equals 0, x equals pi over 2. But down here, we're now in terms of u. Even our domain is in terms of u, so we don't have to replace. Don't replace u if you don't have to. Now, you might be asking, well, how could the AP force us to do this? Well, there's been known questions on the AP where they would make a function, a composite function, something like g of f of x. And then they'll say from dx, and they'll say from x equals, let's say, 3 to 4, right? And you would have to make sure you change these domains right there. So we're going to ask a question similar to this on our test and the quiz. So they can actually force you to make sure that you change those domains. Let's take a look at one more example. Okay? All right, so let's see. Let's do something like this. From 0 to pi over 6, and we'll do something like, let's do tangent x secant squared of x dx. So of course for this one, we know that the derivative of tangent is secant squared, so there's my u. So I'll say u is equal to the tangent of x. Du therefore would be secant squared of x dx. And then dx is just du over secant squared of x. So those are obviously going to cancel. So when I rewrite it, this just becomes u secant squared x du over secant squared of x. Oh, I already knew they would cancel. So now I'm left with everything in terms of u, except my domain. So I have to fix the domain, and that's not too hard to do. When x is 0, u is tangent of 0, which is 1. So I'll put my 1 down there. when x is pi over 6, u is the tangent of pi over 6. Oh no, I forget what that is. So there's my pi over 6 right there. The tangent, I flip it. It's just 1 over root 3. So I go 1 over root 3. And then I can integrate this. Everything's in terms of u. So I'm going to get u squared over 2 from 1 to 1 over root 3. And my FTC step, f of 1 over root 3 minus f of 1. Plug in. We get, what's that? Become 1/2 times 1/3 minus, plug in 1/2. I don't know what that is. I just leave it alone right there. So I hope you guys enjoy these videos. Take a look at the lesson for today. Try these out. They're not too hard to do, and I will see you guys later. Bye-bye.